Hello guys, today we're going to go over 6.1 or discrete and continuous random variables. Now, we've already gone over the first definition, which is pretty much a random variable and a probability distribution. The book states that a random variable takes numerical values that describe the outcome of a chance process. So again, a random assumes values. It could be 65, it could be 37, it could be 51.3. So a variable assumes random values. Now these values is what's going to determine whether you're looking at a discrete or a continuous variable. But one more second on that. And the second definition, which we've already seen before, is the probability distribution, which is pretty much you get the values and their associated probabilities of occurring. Again, for example, rolling a 1, 1 out of 25. Rolling a 7, 1 out of 3. Again, that would be a probability distribution. Now, the biggest ideas you should learn from this chapter is just the definition between continuous and discrete. Now, I'm not sure if I've talked about these variables in previous math classes, but again, the name itself, at least from the continuous variable, you should get a clue. Now, the discrete random variable states a discrete random variable takes a fixed set of possible values with gaps between them. Okay, so for example, the possible values could be 1, 2, 3, 4, 5, 6. And there are gaps between these values. I cannot, be 1.5 or 1.3 or 2.4, not even 2.0, even though I think mathematically it's the same. The fact that you put 2.0 might mean that you're looking at a float, not an integer. We'll get into that a little bit later. There are some gray areas. Now note, don't disqualify variables. As soon as you see a 1.5, don't say, oh, it's discrete. No, because again, the keyword is gaps. That gap doesn't necessarily have to be an integer. You could have the following values, but there are gaps between these values. You cannot end up with 1.15 or 1.13 or 1.27, but you can end up with 1.2 or 1.5. So again, the key word is gaps. There are gaps. It has to jump from here to here or here to here. It has to jump. It cannot flow continuously through all the values within that interval. It's either this or this or this or this or this, or you can't have it. The difference is, let's say, for example, now let's go over the definition of continuous variable, which is somewhat farther down. So I'm going to go into the definition of continuous variable, and then let's come back and talk about how to calculate certain things. Now, the definition of continuous variable is the following. It's pretty straightforward. The name tells you what's happening. A continuous random variable can take any value in an interval on the number line. So let's say I have values from 1 through 5. You can end up with 1.2, you can end up with 3, you can end up with 1.7, 4, 5, 6, 8, 2, 3. Again, any number that falls within that interval is a possibility when you're talking about a continuous variable. Now, if we look at real life, let's see some examples of continuous versus discrete. So for example, the height of a person or the age of a person. Even though you could say, well, no, you have so many days, if you look at the concept of time, it's, continuous. Height, you can be, 6 foot. A person, okay, here's where the gray area comes in. Because people say, oh, you're 6'2" or you're 6'3", or you're 4.4. Welcome to Smurfland. You're 5.9 Averageville. And people say I'm 5.9, I'm 5.10. Also the shoe size, I'm 9, 9.5. So there are gaps, but these are functional gaps. You can't have you shouldn't have a 9.375 foot size. And when someone asks your height, please don't go, I'm 5.9, 7.3. So No, you're just functional values. But in reality, they are continuous. When you actually measure yourself, you are at a very specific true value, which is continuous. So even though in real life we might assign gaps to certain measurements, that doesn't mean that the variable that you should use to accurately represent, not functionally represent, but accurately represent that is continuous. So, for example, weight is continuous, height, blood pressure, pretty much all the biosigns, not heartbeats, for example. Heartbeats would be discrete, height continuous, weight continuous, temperature is continuous. And in, let's say, objects, por ejemplo, money would be discrete because there's an interval. And if we take the dollars, for example, the interval goes from 2 decimal points up towards infinity in theory. Hopefully, you can also go into negative numbers, but not good. But you can have 66.35 cents, you can have 15.20, etc., etc. What you can have is 11.2893 cents. However, if you calculate interest rates from certain banks, you will end up with these mathematical accurate values. They truncate these values and you end up with the cents. So again, you can see how there is certain overlap, and functionally how sometimes certain values are represented as discrete or continuous, but that doesn't change the fact that a variable is discrete or continuous. Now let's go over a couple of other examples for discrete variables. Let's say, for example, tickets for a movie theater. You buy 1, you buy 2, you buy 3, you buy 4, you buy 5. Profe, but in theory, you could buy, 2 and cut off half the ticket. Yeah, I mean, you could, but, functional, these are discrete variables. Rankings, first place, second place, third place, fourth place. Even though that would be an ordinal variable because there's a certain order, it's still considered one of the discrete variables. There are gaps between these. The number of shoes that you have, 10 pairs, 12 pairs, 11 pairs. If you have 10.5, you don't have a pair of shoes, you have a single shoe that's missing. So again, denle un poquito de mente, try to really figure out what's discrete or what's continuous. Okay, that's pretty much the difference. But continuous is that it can take any value within an interval. Discrete, there are gaps and there are some values that it cannot adopt within the interval maximum minimum that you're given. So pretty straightforward. Now, some other things we're going to be discussing. I'm sorry, I just moved the book around a bit. Give me literally 1 second. Is the concept of standard deviation. And standard deviation, pretty much all you have to do is find the variance. We gave this in 11th grade. In 11th grade, we calculated standard deviation manually. In order to find the variance, you find the average of all measurements, and then you subtract every measurement from the mean and square that value. Then you add all those values, and that's the variance, pretty much. In order to find the standard deviation, you do the square root of the variance, and that would give you the standard deviation of your measurements. If you're still not, you still don't remember how to calculate standard deviation manually, the book tells you how to do it, or I can help you in class, or you can just look at last year's books or a whole bunch of videos. But pretty much you calculate the variance first, and then you square root the variance. That gives you the standard deviation. What is new, however, is the following concept. Here, I already found it. And that's, let's say, for example, it's called, this is important, and this is interesting and very applicable in real life. And I love the example they use in the book. Now, the green box says, the mean expected value of a discrete random variable. This is used to predict the mean of a random variable. It has this % chance of occurring this much. Let's go over the example in the book, which is wonderful. Now, if you scroll a little bit down, if you go, where is it? Give me 1 second to find that particular example, which I really enjoy. Oh, it's right above the green square. It talks about a person who has a business, and there are certain payments based on certain services, and each of these services happens at a set chance. So for example, 15% of the time he's going to collect 300, 25% of the time he's going to collect 450, 35% of the time he's going to collect 600, 20% of the time he's going to collect 750, 0.05, so very rarely he's going to collect 900. So what is the average? Well, no, you can't just take the numerical values of how much you make and then do the average of that, because you're not taking into consideration the probability of that particular event happening. So what you do is you take into consideration the chances of that event happening into the average. So all you have to do is, let's say for example, that exact same example, you make 300 in a trip, 15% of the time. You make $450, 25% of the time. You make $600, 35% of the time. You make $750, 20% of the time. And you make $900, 5% of the time. Note, this is a probability distribution, random probability distribution, which means that it should always end up adding to 100. So, either this happens this amount of time and this happens the rest of the time. So it's always going to add up to 100. If it doesn't add up to 100, you're missing the information. So again, adds up to 100. 15, 30, 40, 75, 95, 100. And that's incredibly important. Always confirm that you have all the data sets and the probability adds up to 100% or 1.0. And again, for these types of problems, we're actually going to use the probability, not the percentage. So we're going to turn these percentages given into probabilities as given in the book. I just put the percentage there just to remember that we have to use probabilities. So 15% becomes 0.15. 25% becomes 0.25. 35% becomes 0.35. 20% becomes 0.2. And 5% becomes 0.05. Now again, if you weren't taking probability into account, you would just add these values and then divide by 1, 2, 3, 4, 5. And it would be correct if you were just given the money collected without including the percent chance of each of these events happening. Now, when they give you the probability, it's a slightly different process. All you have to do, and it's stated right there in the book, is add each amount times the chance it occurs, but you don't have to divide. So you would multiply 300 times the probability of that happening plus 450 times the probability of that happening, and so on and so forth. You're gonna, multiply each value by its probability, and then you're gonna add that, no division needed. That's gonna give you the median price of a discrete variable. And that's pretty much it for today. Nothing else needs to be done. Again, pretty straightforward. If you have any questions, please let me know. Have a great day.